right, well, it's time to start the next chapter. This chapter has to do with energy. Hopefully something that you are familiar with. It's something that we all need in order to survive. We've got to have energy in order to do things. And I'm not just talking about energy in regards to like plugging in to the wall. All right, this is also energy that we get when we eat breakfast, lunch, dinner. The reason why we eat is so that we get energy. We also only eat, we also only breathe in oxygen so that we can get energy. That breathing in oxygen actually helps us break, or not helps us, it makes it so we can break down the food that we ate at each one of the different meals, so that we can get the energy out of the bonds that are present within that food. Because what we're doing really is we're taking the bonds that are present in there, which we've talked about previously in regards to how we put things together. And when we breathe in oxygen, we take that oxygen and go clicking and break it apart. And when we break that apart, it gives off energy. And then our body can utilize that energy in order to make it so that we can function and do anything and everything that we do every day, whether it be run around, play video games, whether it be just be, all right? So we have to have that. All right, so hopefully by now you've already downloaded your notes and you got them all handwritten. So now you're looking through your notes and you're going to add things to them as we go through this. So the very first one, letter A, says energy. It's the ability to cause change. Now you may have heard before that energy is the ability to do work. Yeah, that's true, but we're going to add to it now and say that it's not just the ability to do work, it's the ability to cause a change in things, right? It does also have a unit. The unit for it is a thing called the joule, right? It's probably a fairly new kind of unit for you. We've maybe referenced that in the previous chapter. But just know that the unit for energy is the joule, right? Spelled Joule is what joule is. All right, well, there's some types that I need you to know, and those are listed in the next one, letter B. The first one is called radiant. Radiant energy is light. So right now I've got the lights shining down in this classroom, which are probably going to go out in a moment. That's considered to be radiant energy, right? Then we have the second one, letter B, is electrical. Well, there's electricity going through the wires going up to my lights. That's electricity. That's an electrical type of energy. Your phone, when you plug your phone in the wall in order to recharge it, you're using electrical energy in order to recharge your phone, right? And we will talk more about your phone a whole bunch to show on all these types. Letter C, chemical energy. Chemical energy is things like food. The word chemical kind of gets a bad rap. When we think of the word chemical, we go, oh my gosh, don't want to touch any of that stuff. That'll like kill you. You know, chemicals are dangerous. Well, the reality is all the stuff that we've talked about before this, when we talked about all the chemistry things, anything that's made up of matter, anything that's made up of the elements from the periodic table up above me, behind me, that's a chemical. So that means water, H2O, which is made up of the elements hydrogen and oxygen, that's a chemical. Salt, sodium chloride, that's a chemical, right? So you and I are both made up of all sorts of chemicals because we're made up of all sorts of elements that are chemically combined to make us up. So that word chemical kind of gets a bad rap in the idea that chemicals are all bad. No, there are ones out there that are dangerous, but most chemicals are actually perfectly fine, and actually a lot of them are necessary for our survival. So chemical is things like food. Your battery inside of your cell phone actually has a chemical inside of it. That chemical is a form of kind of an acid. And then when we plug it in, what it does is it takes that acid and changes it into a different chemical. And it sticks energy into a bond. And then when you unplug it and you're going to use your phone, those bonds slowly break apart. And as they break apart, it gives off energy and it makes it so that your phone can work, right? Same thing like we talked about a moment ago, and that is that right now while I'm sitting here and while you're sitting on the other side of this computer, is that we're sitting here breaking apart the bonds of the food that we ate, and we're getting energy from that so that we can do the things that we do, right? And it gives us energy. The fourth one, letter D, is thermal energy. Thermal energy is the word for heat. And heat, right now I'm giving off heat because my body temperature is 98.6 degrees Fahrenheit or 37 degrees Celsius. So I'm giving off heat. right? I'm making this video in January right now, so it's cold outside. So inside the school right now, we're utilizing heat in order to keep the school warm. So that's thermal energy. Letter E, this is one that we don't come in contact, or at least we don't want to come in contact with, and that's nuclear energy. And nuclear energy comes from nuclear power. Now, that doesn't affect us around here, right? Yeah, it does. There is a nuclear power plant very close to us. It's actually down in Monroe. If you head towards Monroe, head towards Lake Erie, you'll see it. It looks like the little structure. If you've ever watched Bart Simpson or The Simpsons, and the place where Homer works at, that little structure looks like that. That is a thing called a cooling tower, and that's a nuclear power plant. And if you head down towards Monroe, you'll see one of these right along the coast of Lake Erie. And so we do have that. A portion of the electricity that you're using right now in order to run your computer, in order to run your phone, in order to run your TV, to run the lights in your house, a small portion of that is coming from that nuclear power plant in Monroe. Right? So we do utilize nuclear energy to give us the electricity and other types of energy to make us so that we can live the life that we live. Letter F, mechanical energy. Mechanical energy, think of your car. Mechanical energy is the wheels in your car go around. All right, that's mechanical energy. Mechanical energy is like the gears on a clock. All right, anything that spins and does something, that's mechanical energy. The last one that I added in here because we are going to reference it is gravity. Gravity is the pull of matter on other matter, such as the Earth. Now, I had to put in there because we always commonly talk about just, well, the Earth exerts gravity. But remember, the reality is everything that's made out of matter exerts gravitational pull on everything else that's made out of matter. So actually, people pull towards each other. The chair in your room is actually pulling on you. The desk that's near you right now, that's pulling on you because it's made out of matter. Now, why don't we like all of a sudden go, oh my gosh, I got to pull myself back away. The table's really pulling against me. Well, the thing is, it's really, 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 really small. It doesn't have lots of matter, so it doesn't exert lots of gravitational pull. The Earth is so big, it's got so much matter that it actually exerts a large amount of gravitational pull. And that gravitational pull we can utilize to give us energy. We actually use it when water rains on top of a mountain. Because of gravity, that water slowly flows down the mountain. We can utilize that gravitational pull, that downward flow of the water, and we can get that to turn things called turbines. Oh, there's mechanical energy, something spinning. And when it spins that, we can then use that to make electrical energy. And then we can send the electrical energy out to people like you and I, so that we can have electricity in our house so that we can do all the things we need to do. We can turn on our lights. Oh, that's radiant energy. We can turn on a heater. Oh, that's thermal energy. We can make mechanical things spin. That's mechanical energy. So there's all sorts of types of energy, right? Now, along with that types of energy, there are states of energy. And every single one of those types of energy can be one of these two states of energy. And the two states of energy, which I'm sure you have heard of before, are kinetic energy and potential energy. I don't want you to get confused on this and go, well, that's just another type of energy. No, we can have the types. We can have radiant energy. We can have potential radiant energy. We can have kinetic radiant energy. Probably some other ones that would work better would be like chemical energy. I can have potential chemical energy. That's going to be in the way I love to use this one is think of your phone, right? Your phone is half charged. Does it have the potential to work? Yes, it does. You can turn it on. Is it going to last all day probably for you? Probably not. I mean, I don't know in the case of your phone, but chances are if you only got half of a battery showing on your phone, you're gonna be like, man, my phone's gonna die halfway through the day. I better charge it up. Right? So that's the potential chemical energy that's located inside your phone. Now, when you turn on your phone, then that potential energy is going to turn into kinetic chemical energy. In other words, it's going to turn into energy that's going to be used on your phone. And then slowly throughout the day, Your phone actually takes that potential chemical energy and turns it into kinetic chemical energy so that you can utilize your phone. And we slowly keep changing that state of energy to an energy that we can use. Okay. So I do want you to understand that we basically now have two different classifications. We got types of energy, which we listed a moment ago, and then we got states that that energy can be in. It can either be kinetic or potential. Okay. With the idea of states of energy, I'm going to relate this to matter that we talked about in an earlier chapter, and that is like water. Water is a chemical. It's a type of matter. Okay. But we can have water in three different states. It can be a solid, ice. It can be liquid, which is water, like liquid water, or it can be a vapor, which is water vapor or gas. So we can have that in all three states. Is it the same stuff? Yeah, it's always water. Okay. All we've done is change its state. So understand that this kinetic and potential energy, those are different states of energy. Okay. I'm getting down near the end of my time, so I'm going to stop and we're going to go on to part number 2. So we'll see you in part number 2 in just a minute.